Hey, this is Jim Damschroeder with Portfolio Think Tank. I got a quick video today about how to measure portfolio diversification. On my monitor here is the Portfolio Think Tank website, and it's a page just shows an infographic called How to Measure Portfolio Diversification. If you want to grab the PDF version of that, if you go to portfoliothinktank.com and then you scroll down to the bottom under Investor Resources, you can go ahead and click this to jump into the PDF. So I'm going to just walk you through this PDF, and at the end of this video you're going to know how to measure portfolio diversification. A lot of confusion about diversification, and the investment industry hasn't really helped to clarify that over the years. So this is a pretty definitive way of measuring it, and a good way to think about how to do it is start with the number of investments that you have in a portfolio. So say we're measuring the diversification on the S&P 500. That's what the infographics doing. So we here have our example 500. But this is a very false sense of diversification, which is why we say it has high naivety. And anyone who thinks that having 500 things you have good diversification, you've really not analyzed it correctly. At the end of the day, we've realized that diversification is really a function of two things. It's the number of things that you own, and it's the number of it's the interrelationships or correlations between those things. So this is a process which does that. If you've got 500 things, and even if you have them equally weighted, you put all these assets into a space. A mathematician would call it a vector space, and then you measure the dimensionality of that space. So the space that you put 500 things in it's called an ambient dimension. And then what happens is we take that ambient dimension and we're able to reduce that dimensionality down as we wring out all of the redundancies that are inside of those 500 dimensions. So the next level down, when we go from asset count, is we go to what's called a spanning dimension. And at this level, we've basically just normalized the portfolio to account for the weighting of those 500 assets. In most stock market indices, including the S&P 500, they're what's called a market cap weighted index. And when we account for investing 8% in Apple versus 0.1% in the 499th biggest investment, that normalization now measures the portfolio in a little bit more of a precise way of measuring diversification. It could also be called an equally weighted equivalent, and it's also the spanning dimension. Our 500 has now dropped down to 194. But this is still the easy part of diversification, and it's still really easy to mess this up. So this is really just sort of an interim step. Technically, I would call this a measure of concentration, not of diversification. So let's take our next step down. Now what we've done is we have wrung out all the rest of those redundancies after accounting for the weighting of the assets, and now after also accounting for the interrelationships or the correlations amongst those assets. Effectively, what we end up with here in our example is 21. That means we've got a portfolio. It might have 500 things in it, but it behaves as if, this is like a statistical abstraction, but it behaves as if it has 21 independent acting investments. So sort of shocking that you go from 500 to 20, and it really does show how most people think of diversification. They probably put too much stock into the number of things and not enough stock into the correlations of things. The trick that I've discovered over the years is that when you want to have a more diversification, it's easier to have more things in there, but now each thing that you add has to be added where it doesn't detract from the average correlation amongst those assets. So that's kind of what it is, taking you through an example. Now I'm just going to go into how we actually measure it. What do these different dimensions mean? You can see here, we call it the intrinsic dimension. The intrinsic dimension is when we took that ethereal 500 dimensions and then we wrung it down to a spanning dimension, which is the smallest dimensionality that can enclose our data. And then we're going to wring it down one more time, where we'll call it an intrinsic dimension, which is really just the essence of that data. And I'll show you what that looks like here. This is a chart. We call it the diversification source chart. And this is not the example of the S&P 500. This is an example of like a FANG portfolio. Up here in the top right, this is equal to the number of assets that you have. So in the S&P 500, our x-axis would be 500 and be 500 tall, and we'd have a really skinny line in between. What we're doing is this diagonal. It's called the line of equivalence, and the degree to which our graph dips under that line shows how the diversification in that portfolio is non-equally distributed. If it was equally distributed, our graph would mimic this line. This is called the Gini coefficient, and the Gini coefficient is also normally used to measure diversification or particularly wealth distribution. So if everybody had the same amount of wealth, then we would graph the number of people and the amount of wealth that they had, and it would be right on this diagonal line, showing that everybody had more wealth. As you add one more person, you add more wealth to the system. So when there's greater disparities, that graph drops down, and it shows how it doesn't matter how many more people you add, the amount of wealth doesn't change. That shows a great disparity. So in this sense, we're using the Gini coefficient, the mathematics of the Gini coefficient, to measure the the distribution of what's called an eigenasset. So an eigenasset, you could also think of it as a statistical factor. It's a dimension. So in the S&P 500 example, we ended up with 20 different investments. The way that math works is you take this chart. You have 500 over in this corner, but the percentage of volume that the graph fills up under the slope of equivalence is just a small fraction, so that the resulting volume would only be 20. So yeah, the volume might be 20, which equals here 11% of the triangle. The Gini coefficient answers the question, what percent of diversification does this portfolio have given the number of investments that I've made? All right, I'm going to jump out of this and I'm going to show you a couple examples. Here is a portfolio built of what we call styles, investment styles. This is your large cap, mid cap, small cap, growth, blend, and value, and it's a matrix of those different styles. As you can see here, it very closely matched the index. There's not a lot of differentiation amongst that type of view of styles. So let's look at the chart. We ended up, let's see, excluding cash, we had 9 different investments. It looks like We invested in 6 of them. So the top value on the chart is, in this case, it's not 6, it is 5. It's just because there was some redundancy there in that holding approach as it diverged from equally weighted. And then as it dips down, you know, the average of this is going to give you a value where the total volume is the equivalent here of having 3 dimensions. So this portfolio, 6 things, but basically it behaves like a 3-dimensional portfolio. Not great. Here's a second example. I just switched my screen. Now we're in a portfolio of sectors. We found that sectors tend to be a little bit better job of dividing the universe in a manner that offers non-correlation. And here's the chart on that. Looks like it fills it up a little bit better. Still, see if we're apples to apples. Yeah, we've got 7 different investments now. And our value, instead of 3, is about 4.5. So nearly a 50% improvement in diversification by cutting up the universe in a manner that offers better non-correlation. We'll be able to see that too, looking at the correlation matrix. You can see a lot of like 0.5s and 0.7s. Looks like our low value is 0.41. I'm going to switch back to the sectors. We'll look at that correlation matrix. I see a lot of 0.9s and 0.8s. Maybe it looks like a low value of 0.65. So that non-correlation gave us better diversification, and there's no limit to the amount of diversification you can get. So using this process of calculating the dimensionality of a portfolio and then calculating the Gini coefficient of the energy spectrum, or dimensions of that, is a pretty definitive way to measure diversification. You can use this approach to measure diversification not just of a portfolio of investments, but of any population, whether it was a collection or a student body or just a list of different attributes of any population. Alright, I hope you got something from this video. If you want to measure diversification in your portfolio, go ahead and fire up Google and head over to portfoliothinktank.com, and you can go ahead and just punch your portfolio in this system as it is, and that gives you a good sort of starting spot to see where your diversification is, and then you can choose to do something about that. So get smart on diversification. It's a really powerful thing for your investments. I'll save that for another video. Thanks for your time. Have a great one. See ya.